So the next topic in Python is sets. So as we have studied in mathematics, set is a collection of unique elements. Same concept goes here. Suppose we have set. Okay, so this bracket, as you can see, first let's write the elements. Okay, now as in list we used this bracket, that is square bracket. In tuple we used round brackets, and in set we are going to use curly brackets. So keep this in mind. Now if we print the type of our set, you will see it as set, right? So set should be a collection of unique elements. As you can see here, all the elements are unique. So there's one more thing that you need to remember, that in set indexing is not supported because we don't have a proper sequence. Okay, so this is a thing that you need to keep in mind. I'm writing here it as a note. Indexing is not supported in sets. Okay, now next let's understand the operations that we can perform in set. So the first operation is to add. Okay, now let's see this operation, how this works. Let's take this set from here. Now we have to add something. Set dot add. Okay, what we want to add? Let's suppose we want to add 6 to the set. We don't have 6 inside set. Yeah, we don't. So let's add 6. So what it's going to be, we'll print our set. As you can see, 6 is added. Taking another example. Right, let's copy the set. Okay, so we have the same set. Now we have to add, let's add 100. And now print our set. Now if we run this, you see 100 has been added. Now in set, there is no ordering. It does not have a proper sequence. So your new number that you append will be added anywhere in the set. Let's take another example. Suppose I'm adding 1000 this time. And now if we print our set, as here you can see 1000 is added here, right? Now if we add 456 is added here. So it doesn't matter, the order in set doesn't really matter. That's why there is no indexing in set, right? So you have to keep these things in mind. Since here, see here I've added 456. So 456 should have been after 47, right? But it is between 3 and 5. So there is no sequence or ordering in set, right? So this was the first operation, add. And moving on to the second operation, that is copy. You can copy a set. Suppose you have this set. Equals to. Now if you want to copy this set, you can simply use set dot copy. Okay, so there is nothing in this. You'll just use set dot copy, and if you run, you'll get that same. Then we have third operation, that is difference. Okay, so how do we use this? Suppose we have our set 1. 5, 6, 7, 3, right? We have set 2. 1, 2, 5 and 1. Let's take it as 3. Now if we perform difference of these two sets, we'll just write set dot difference, and inside this we'll pass our two sets, right? Let's name it as set 1. Set 1 comma set 2. And now if we run this, we've got set as our output. Because the difference here is null. So let's increase the values so that we get some difference. And now if we run this, we've got 7. The difference between both of them is 7, right? So this is how you can find difference between sets. Now if we move to our next, we can discard element. So how do you do this? Suppose you have a set. Now if you want to discard any number, set dot discard. Let's suppose you want to discard 7. And now if you run the, sorry, I didn't print. And now if you run this, you've got 1, 2, 3, 5 as your set. So like this you can delete any number by using discard, right? You can also find intersection of two sets. Suppose you have the set, let's give it a 4, and let's take another set which is set 2 and 3, 6, 7. Now if you want to find intersection, you'll just write set dot intersection, right? And the name of two sets, that is set 1 and set 2. And now if we run this, you've got 3 as an intersection because 3 is the common element between both of the sets, right? So like this you can find intersection. Another operation is pop. Fifth was intersection. Sixth you have pop, right? Now you have some set. And let's suppose you want to pop. Set dot pop you can use, and now you'll see 1 will be popped. You know, from the starting the elements are being removed. So now you'll see 2, 3, 5, 7. Okay. Now next, after pop you have another function or another operation you can say, that is remove. Now again, now if we use set dot remove, here you need to pass a parameter. In pop you don't need to pass a parameter. If you want to pop elements from the beginning, you can simply use pop. But if you want to remove a particular element, let's suppose I want to remove 5, right? And now if I print my set, we see here 5 has been removed. So like this you can remove a particular element. And another operation is union. We just used intersection, now let's use union. So union is also very easy. Let's suppose we have a set 1, 2, and let's suppose set 1 is your 1, 2, and your set 2 is 3 and 4, right? And you want to find union, so you'll simply write set dot union and pass your two sets. It's very easy. And now if I print our set, you'll see 1, 2, 3, 4 as your 1, 2, 3, There should be 4 also. Wait a minute. Yeah, 1, 2, 3, 4. So like this you can perform union. And these were all the operations in set. There is also one more operation. Let's suppose we have a set 1, 2, 3, 4. And if I want to clear this set, you see, function set dot clear. I'm just printing the set here. This is not required, but you can clear your set. And now if you print this, you will see an empty set, right? So like this you can use clear function also. 9th, I can say clear. This was all about the operations that we can perform on set. Now let's move on to another topic in Python, that is typecasting, which is very easy. Now typecasting means that we are changing from one data type to another. Suppose we have int data type and we are changing it to float, or we are changing a simple number into a complex number, right? We're just changing data type. So there are two types or two categories. First is known as explicit typecasting, or also known as forceful typecasting. Second is implicit typecasting or automatic typecasting. Okay, so these are the two types of So these are the two types of typecasting. Okay, now next. Okay, so next let's understand explicit or forceful typecasting in detail. Suppose we have A as 5.6, right? As from this you can see that A is float. Now what we do is, if we want to change this into integer, what we do is we use int and then we pass A inside it, right? You know what, first let's print the type of A here. You'll see it as float. Yes, float. Now what we do is we want to change this float to int. So we'll take another variable, we'll write int, and whatever we want to change we'll pass inside this bracket, right? Now if we run this, output has gone. Now what we do is we print our B. Now let's run this. As you can see, 5.6 is converted into 5. Now if we print the type of B, you see it as int, right? So initially our A was 5 and it was float, 5.6 and it was float. Now our A is 5 and it is int. So this is known as forceful typecasting. Okay, let's take another example where our A is 5, x is 5, and we are changing it into float. We are changing x into float. And now if we print our x, we'll see that, we're not printing x, we're printing y. Now we see that it has changed to float, right? If we print the type of y, it will show as float. Yeah. So initially our x was 5, now it is 5.0. Initially it was int, now it is float. This is known as typecasting, where you're changing the data type, and explicit typecasting because you're forcefully changing it. Now, okay, so now coming on to implicit typecasting or automatic typecasting. Suppose you have numerator as 20.5 and you have denominator as 2 and you're performing division, so it will be numerator upon denominator. And now if we print div, you see here the data type of div is automatically converted to float, where denominator was int and this was float, but the answer is float, so automatically the data type has been converted. And now if we print the type of div, you'll find it as float. So this was all about typecasting, how you can forcefully change by forcefully writing here the data type, that is float, and how automatically it can be changed by adding one float value and one int value. Here you get automatic float value. So this was typecasting.